This video, we're going to talk about how to describe transformations of square root functions. So remember, in the previous video, we talked about how the parent function is f of x equals the square root of x. So that means that all other square root functions will be transformations of this original parent function. And we can represent all square root functions then as a square root of bx minus h plus k, where a, b, h, and k are constants that will affect how the graph is transformed. So remember, there are three types of transformations that we'll talk about: shifts, which are translations, left or right or up or down, stretches and compressions, and reflections over the x or y axis. We have these notes in our study guide that are going to help us figure out how to identify the type of transformation and also how to write a transformed equation given a description. So let's go ahead and look at some examples. So when we're identifying transformations from equations, remember the first thing we want to do is identify or highlight the terms that are different from the parent function. We're going to label these values as a, b, h, or k, and then use the study guide to help us identify the transformation. Remember, we always want to double check our answer by graphing in Desmos so that we can verify what we identified is correct. So suppose the function f of x equals the square root of x is transformed to g of x equals the square root of x plus 3. Let's describe the transformations. So I'm going to start off by highlighting what I notice is different from the parent, which is that plus 3. So that plus 3 is giving me an x plus 3 situation. So I have x plus h. Remember, that's going to represent a shift left. So that x plus 3 is going to be a shift left 3 units. And remember, those horizontal shifts are kind of like what's the opposite of what we think they would be. Okay, so that's why it's always a good idea to graph in Desmos and verify. So I'm going to type this parent function, which is the square root of x, and I'm going to go to the next row and do my transformed function, which is x plus 3. Remember, this time the plus 3 is inside the square root. Remember, you can adjust the graph settings so that you can see this a little bit better. I'm going to get rid of the minor grid lines, and then I'm going to do step 1 for x and y axis. And so I can now count the squares to see how it's been transformed. You can see the red, which is the parent function, is shifted to the left 1, 2, 3 units to form the graph of the transformed function. So now you can go ahead and pause the video and try doing this example on your own. So here we have 1/5 times the square root of x. So notice that 1/5 is the value of a. Okay, so that 1/5, if I look at the absolute value of 1/5, that is between 0 and 1. Okay, so since the absolute value of 1/5 is equal to 1/5, and that is between 0 and 1, we know we have a vertical compression. Okay, and how can you tell this is a vertical compression? When you look at the graph of both in Desmos, notice how this graph looks flatter. So that means that it's vertically compressed from that original parent function. Now let's look at this example. Here we have f of x equals the square root of x is transformed to g of x equals -4 square root of x plus 3 minus 2. Describe the transformations. So first I want to notice what's different from the parent function. I have a -4, I have this plus 3, and I have a minus 2. So let's first think about what happens because of that -4. So I'm going to study the -4. And first, remember, I need to figure out what the absolute value of -4 is. The absolute value of -4 is 4, and that is a number that's greater than 1. So according to my chart, that means I have a vertical stretch. And also, since that -4 originally is less than 0, that's going to be a reflection over the x-axis. Okay, so that means I have two changes because of that. I have a vertical stretch, and also, that's going to be a reflection over at the x-axis. Now let's look at that x plus 3. So that x plus 3 is giving me one of those x plus h situations, right? So I have an x plus h. My chart here tells me that's a horizontal shift left. So it's going to be shifted left 3 units. And then finally, I have this -2 on the end. That -2 is like this minus k, right? So I have a vertical shift down when I have a minus k. So that -2 is going to cause a shift down 2 units. Okay, so this is kind of what I figured out based on the information in the study guide. But remember, I always want to double check in Desmos to make sure I got this right. So I'm going to do -4, and then from the keypad, choose square root. do x plus 3, and then remember, click outside the square root because that minus 2 goes on the outside. And you can see that, in fact, this graph, I mean, the reflection you can see pretty quickly, right? Also, it is vertically stretched. See how this graph is taller than that original graph? Let's look at the shift. So it went from, like, the starting point went from 0, 0 to -3, -2. So it was, in fact, shifted left 3 units and down 2 units. So now you can pause the video and try doing this example on your own. You can see here there's quite a few transformations going on in this problem. We have the 1/3 in front, so that's going to be a value of a. So that's going to represent a vertical compression because the absolute value of 1/3 is between 0 and 1. That x plus 1, that's going to create one of those x plus h situations. So that's going to go to the left 1 unit. Up 5, that is a value of plus k, so that is going to go up 5 units. When we look at our graph in Desmos, we can see that it is, in fact, vertically compressed because this graph is flatter than the original function. Every point has been shifted to the left 1 unit, and it has gone up 5 units. So now let's go the other direction and let's write transformed square root functions. Remember, when you're doing this, you want to underline or highlight the key terms and phrases that represent the transformations and determine whether these are values of a, b, h, or k. Then you'll use the study guide to help you identify the transformation and then write the equation and graph your equation and the parent function in Desmos to verify that you've written the equation correctly. So the function f of x equals the square root of x is translated 4 units to the right to form g of x. What's the equation of g of x? So we hear the key word is translated 4 units to the right. If I look at my study guide, it says translated right when we have x minus h. Okay, so that means I'm going to have x minus h here. And since that value is 4, that is going to be now x minus 4. So that means I'm going to go to my function now, g of x, and then I'm going to write this as the square root of x minus 4. I'm going to go ahead and graph this in Desmos to make sure that I've written the transformation correctly. So I have x minus 4 here, all under the square root. And you can see that from the parent function in red, every point has been shifted to the right 4 units. So here we have another example. It says the function f of x equals the square root of x is vertically stretched by a factor of 3, reflected over the x-axis, and shifted up 5 units to form g of x. So vertically stretched by a factor of 3, if I go to my chart here, it says a vertical stretch when the absolute value of a is greater than 1. So that means that this is going to represent the value of a. We also have that it's reflected over the x-axis. So reflected over the x-axis means a is less than 0. Okay, so I need to make sure and include that. And then also it says shifted up 5 units. So if I look at my chart, shifted up is when I have a plus k. So those are going to be the values that I need to put in my equation. So I'm going to go ahead and write a is 3, but since a is less than 0, I'm going to make that a negative 3. And so I have a plus k that is shifted up 5 units. So I'm going to make that a plus 5. So when I write g of x, I'm going to do a is negative 3. I have the square root of x. And then that plus 5 needs to go on the outside since it's a vertical shift. Let's go ahead and now enter this equation into Desmos and see that we've done it correctly. So I have negative 3 square root of x. Click outside the square root to do plus 5. Okay, so you can see that it has been reflected. It is vertically stretched because this graph is taller than the original graph. And you can see that the points have been shifted up 5 units. So now you can go ahead and pause the video and try doing this example on your own. So let's see what's going on here. We have a function f of x equals the square root of x that's vertically stretched by a factor of 5 and shifted left 3 units to form g of x. So vertically stretched by a factor of 5 means that a is greater than 1, so we have 5. Shifted left 3 units means we have x plus h, so that's going to be x plus 3. So the new equation is going to be 5 squared root of x plus 3. If we type it in Desmos, we can see that this graph is in fact vertically stretched. It's a lot taller than the original, and every point has been shifted to the left 3 units. So remember, you can compare a transformed square root function in the form g of x equals a squared of bx minus h plus k to the parent function f of x equals square root of x to identify the transformations that have occurred. You can also use this to write equations of transformed functions, and remember to always use Desmos to check your equations and transformations.